Hey guys, so we're going to work on the homework. I'm going to go through the four first Lewis dot structures to show you how to do those. So the first one we have is H2S, and the first step is always to find the total number of valence electrons. We have two hydrogen. Each hydrogen has one valence electron, so that gives us a total of 2 for that one. Our sulfur has a total of 6 valence electrons. So that means on our Lewis dot structure, we need to account for 8 valence electrons. So if I write this out, we have sulfur, and I'm going to start by drawing single bonds to the hydrogen. Now remember that each bond holds 2 shared electrons. Okay, so far if you count the number of electrons, we have 2, 4. We have 2 here and 2 here, but we need a total of 8. Now, I can't put those electrons on hydrogen because hydrogen can only have a single bond. So those extra electrons have to go onto sulfur. I know I can't put it here as a double bond because then hydrogen would have too many bonds. So when we're done with that, that is what our Lewis dot structure looks like. So if I were to redraw it, it would look like this, with 2 electrons here and 2 electrons here. Now, if you're going to figure out the VSEPR for that, remember we have to count how many electron domains we have around the central atom. Here's our central atom, okay? And when we count how many we have, we've got 1, 2, so we have 2 bonding domains, and we have 2 lone pairs. So when we look that up on our chart, you will see that that is going to be linear, pretty much exactly how we've drawn it. So now let's go to the next one, which is CH2Br2. Remember, the first one generally tends to be your central atom. Carbon will pretty much always be your central atom. So first we need to count how many valence electrons we have. Carbon has 4. Hydrogen has 2 each, or 1 each, with 2 hydrogens, so that means a total of 2. Bromine has 7 each. We have 2 of them, so that would be 14. So that means we have a total of 20 electrons that we need to account for in the Lewis dot structure. So I'm going to start by drawing my carbon. I'm going to add the hydrogen, and then I'm going to add the bromine. So if we count how many electrons we have so far, 2, 4, 6, 8. So we still have 12 that we have to account for. So remember that bromine has a total of 7 electrons each. So I'm going to add them to the bromine. So there's 6. There's 6 more. And that is your total Lewis dot structure. We didn't add any electrons to the hydrogen because remember they can only hold a single electron or 1 bond, whereas bromine has an area for 1 bond as well but can hold the other electrons. So now if we take a look at that, let's rewrite that so it's a little bit neater. It looks like this. Because we're doing VSEPR, we don't really need to account for those electrons on the bromine. But if I look at this and I count how many domains we have, and you guys could probably do this, 1, 2, 3, 4 domains, and they are all bonding domains. So therefore this would be tetrahedral. Pretty simple. That's usually the easiest one is when you have something like that with 4 bonding domains. Those are usually the easiest. Okay, so let's go on to number 3. This one stumped a lot of you guys, and class got kind of crazy, so I want to make sure that we understand how to do this. So let's take a look. First, again, we count all of the valence electrons. Sulfur has 6. Oxygen each has 6, and we have 3 of them, so that's a total of 18. So that means we have a total of 24 electrons that we need to account for in the Lewis dot structure. So let's start by drawing our sulfur. Oops, ignore that. Then we're going to draw our oxygens. Always start with a single bond and kind of see where you're at. So far we only have 6 electrons. So if I go ahead and add electrons to all of the oxygen to fill their octet rule, let's count how many electrons we have so far. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. However, there's a problem here. Sulfur's octet is not filled. And remember that we really want to fill the octet rule with these. So this is where you start looking at double bonds, okay? So basically, let's take a look at what we can do here. What we can do is we can add a second bond here and then take away a pair of electrons from this. Okay, so if I were to redraw this, let me show you what that would look like. It would look like you have sulfur, oxygen, oxygen, double bonded oxygen, okay? That allows us to have 4 bonds around the center atom. So that's octet is filled. When we look at the electrons on oxygen, all of the oxygen are filled as well. So that is what it looks like. Now, this has something called resonance. We haven't really talked about that in class, but basically, if you think about resonance as being this double bond right here could actually be in any other position, and it kind of filters back and forth through that. Now, when we look at what shape this is, we look at the bonding domains, right? So if I were to highlight the bonding domains, we have one here, one here, one here. So we have 3 bonding domains. That would be trigonal planar on your sheet, if you take a look at that. Okay, the last one for the homework is HCN. So again, we start by counting our electrons. Hydrogen has 1. Let's see, let's do different colors. Carbon has 4. Nitrogen has 7. So that gives us a total of 12 electrons that we need to account for. So let's start with carbon in the middle. We know that hydrogen can only have a single bond. We know that nitrogen needs 4. It needs its octet filled, and carbon needs its octet filled. So far on carbon, if you look at what we have on carbon, we actually only have 4 electrons so far on carbon. We need 4 more. So when I look at that, I think, okay, well, I can't put those extra electrons here. I could do this, right? And that would fill carbon. However, remember that nitrogen also needs its octet filled. That's what everything goes for. And right now, it only has 2 electrons so far. So that's not going to work. We're not filling the octet role of nitrogen. So what if instead we do this and we add a triple bond here? So that's 6 electrons here, 2 electrons here. So carbon's octet is filled. Is nitrogen's octet filled? Not yet. But so what I'm going to do then is add 2 electrons to nitrogen. Now everybody's happy. We're all good. Let's redraw that so everybody knows kind of what that mess looks like. So we have carbon triple bonded to nitrogen. Nitrogen has a lone pair, and hydrogen is bonded to carbon as well. When we look at this, we decide for VSEPR how many electron domains it has. It has 1 domain right here, 1 domain right here, so it has 2 domains. Both are bonding domains, so that is linear. I hope this helped. If you had any questions at all, please email me, but we will also go over this in class.